integrated 1, 11, 1, 2. In the space at right, construct 2 intersecting circles so each passes through each other's center. So no worries. We'll go ahead and just make a circle. And then it doesn't really matter which point, as long as I'm on the circle. If I make another circle, I will get something that looks like that. From there, it asks us to go ahead and read through C and D. And really what's going on here is it's just asking us to kind of name these points and make this shape. And they want us to know, hey, is this a parallelogram or a rhombus? Well, hopefully it's obvious to everybody that this is indeed a rhombus because it has equal side lengths, right? A rhombus is like a squish square. I know these side lengths are the same because from the center over. Well, these have to be the same, right? Because I didn't change the compass. They was the exact same size circles. So the radius was the same. Whether I'm going from this point to this circle or this point to this circle, the radius was the same. So I have a parallelogram. Now, they also want us to sort of do some other things here. And I want to point this out that, and this goes back into the 11.1 or chapter 11 intro video. I have created a perpendicular bisector, essentially. I know that these sides are the same length. I know that these sides are the same length. And I know that I have 90-degree angles the whole way around because of triangle congruence and CP/CTC. Again, I don't want to get into that too much right now. I do in the introduction video explain why we know these triangles are congruent, and because of that we know the sides are the same and the angles are the same, or that CP/CTC corresponding parts are congruent, triangles are congruent. But I just don't want to keep explaining the same thing over and over in different videos, so you can go watch that if you're not quite sure why. But that was pretty easy, pretty neat. Just doing that, we've got 2 circles connected together gives us a rhombus, 2 perpendicular bisectors, and 4 corners. Pretty amazing. All right, so from here, construct a perpendicular bisector of KM. So how are we going to get a perpendicular bisector? Again, I have a length here. It doesn't really matter as long as it's more than halfway, so I'll make that a little bit bigger. And we'll do an arc. Actually, I haven't messed around with changing colors in a while, so let's change the colors. So we'll do an arc on one side. We'll do an arc on the other side. And now, if I connect those arcs, you can see that I am going to have a perpendicular bisector. I know that these are the same length, and I know that these are 90-degree angles. And again, that's all explained in the introductory video. But just a quick perpendicular bisector right there. Alrighty, let's move along, and we're going to do an angle bisector. And again, I do an angle bisector, and I explain the angle bisector in the introductory video. So I'm just going to do a real quick one right here and not spend a ton of time on it. But I'm going to go ahead and take this length and go ahead and get my arcs. And again, don't forget, I am constructing congruent triangles, whether it looks like it or not. That is what is happening. And now if I connect this point across, I know that these angles, this angle here is the same as this angle here. Again, because of congruent triangles, and CP/CTC, or corresponding parts of congruent triangles, are congruent. Finally, they give us 2 side lengths and an angle and ask us to essentially make a triangle that is similar to that. So I'm going to say this is side length 1, this is side length 2, and this is the angle that they want us to use. So I'm just combining a bunch of things in this one, so no big deal. I'll go ahead. First of all, I think the easiest thing would be to do to get this angle first. So I'm going to go ahead and construct this angle. I'm going to steal this angle and copy it over. So I'm going to go over here. And again, this is something I think we learned in 11.1.1 maybe, how to steal an angle. So make sure you know how to do that. I'm going to steal this arc. Uh-oh, didn't mean to do that, but doesn't matter. Now I will go over here and I need to mark this distance. There we go. So I will steal this distance and go over here and copy it. She's easy for me to do. Okay, so at this point, I know that if I connect these points from here up, I've copied this angle. So this angle is the same as this angle. And again, you can watch video 11.1.1 if you want. Now I need to steal these side lengths. So I'll switch the color to blue, why not? So let's go over here and I'm gonna steal these side lengths. Well, I guess I'm not, if it's gonna, the color's gonna be in the way. So I'm gonna go here, I'm gonna steal this side length. So we'll just make this side length blue. So there we go. I know that this distance here, I know that this distance here is the same as this distance here. And now I will steal this side length on this one. Go ahead and steal that here. And I'll steal that here. And again, now I know that this side length, I'll put 2 here to show that it's different, is the same as this side length. So last thing I need to do here is just connect where these things meet up at. This point, oh, whoops. I want the straight line tool, my mistake. This point meets up with this point. So there we go. This side length's the same as that side length. This side length's the same as that side length. And this angle is equal to that angle. So I have it. It looks ugly. There's a bunch of stuff in the way. But if you focus on the black triangle right there, that is the part that matches up.